Welcome to helpyourmath.com. In this video, we're going to look at several examples of solving linear inequalities and solving absolute value inequalities. In our first example, we have a linear inequality. We want to solve it, graph the solution set, and write the solution set in interval notation. So in our first example, we want to get e by itself. We'll treat this kind of like an equation, so we'll take away 9 from both sides to isolate the variable. We get negative 2e is less than negative 24. And then to get e by itself, we need to divide both sides by negative 2. But remember, with inequalities, when we multiply or divide both sides by a negative, such as negative 2, we have to flip the inequality symbol around. So this is going to become e is greater than positive 12. So we just want to be really careful. Anytime we multiply or divide we need by a negative, we need to flip the symbol around. So now e is greater than 12. So that's solving the inequality. On a number line, 10, 11, 12, 13, 14. This would be an open circle over 12 with an arrow going to the right. In interval notation, since we're talking about numbers bigger than 12, that means that the solutions start at 12. Since 12 is not included, we use a parenthesis, and they go up to infinity, and we close parenthesis. And this would be our final solution for the first example. In our next example, this is also a linear inequality. So we have multiple variables, we have some simplifying we need to do. Let's jump right to the distribution. So we have 3 times 2x is 6x. 3 times minus 7 is minus 21, plus 4x is less than or equal to 5x minus 8. We'll combine our like terms over here. 6x plus 4x is 10x. So 10x minus 21 is less than or equal to 5x minus 8. I'm going to get all the variables to the left, so I'll take away 5x from both sides, and I'm going to move all the constants to the right, so I'm going to add 21 to both sides. Okay, so I'm doing the same thing to both sides, and I'm not doing anything weird yet, so adding and subtracting won't change inequality signs. 10x minus 5x is 5x. The negative 21 and positive 21 cancel. These cancel, and here we're left with 21 minus 8, or negative 8 plus 21 is 13. To get x by itself, we'll divide both sides by 5. I'm multiplying by positive, so that does not affect the inequality symbol. It will stay 13 over 5. Or you can rewrite it as a mixed number. 5 goes into 13 2 whole times with 3/5. You can also convert it to a decimal. It would be 2.6. On a number line, so I'm not going to put fractions, but you're more than welcome to if you feel up to it. I'm just going to use the whole numbers here. 2 and 3/5 is in between 2 and 3. A little bit closer to 3, and it's going to be a closed circle since 2 and 3/5 is included. This says that it's less than, x is less than, so it's all the numbers less than 2 and 3/5. That would be an arrow going to the left. In interval notation, there is no smallest number smaller than 2 and 3/5, so we would say negative infinity to 2 and 3/5. To include 2 and 3/5, we will close it with a bracket. So that bracket indicates that 2 and 3/5 is part of the solution set. And that would be our final solution there. Our next example is an example of an absolute value inequality. So we're looking for all of the numbers whose absolute value is bigger than 4. So there's going to be 2 cases here. This is called a disjunction because of the greater than. So this indicates to us it's a disjunction, which means we have 2 distinct sets in our intervals of numbers in our solution set. So this is a disjunction. We consider it to be an or scenario. So either x can be bigger than 4, right? Because if you take the absolute value of 5 or 6 or 7, those are all numbers bigger than 4. Or x can be less than negative 4. Because if you take the absolute value of negative 5, negative 6, negative 7, those numbers are all bigger than 4. So we have 2 distinct intervals of numbers on a number line. We can say negative 4, 0, 4. Over negative 4, that would be an open circle with an arrow going to the left. Over 4, that would be an open circle with an arrow going to the right. So this is where all the solutions lie, here and here. In interval notation, to represent x is less than negative 4, because usually we do put the smaller set, or the set containing smaller numbers first. That would be from negative infinity to negative 4. And then we also have a bunch of solutions from 4 to infinity. And I use the parentheses for the endpoints for negative 4 and 4 because they are not part of the solution set. So this would be our final answer for this example. This example, we have the absolute value of h is less than or equal to 7. This one, when we have less than, this is called a conjunction. And you can either write this as a compound inequality, or you can use the word and to write the 2. So H has to meet 2 requirements because it has to be less than 7 or equal to 7, but it also can't be so far away from 7. Like if it's negative 14, all of a sudden this is a false statement because the absolute value of negative 14 is 14, which is not less than or equal to 7. So there's some end to this. So usually when we do conjunctions, we write them as a compound inequality. And when this is isolated, you take the endpoint and we just negate it. So it would be negative 7 is less than or equal to H, which is less than or equal to 7. We want to make sure with these compound inequalities that the variable is isolated in the middle, which it is. So we're done solving this one per se, but we still need to set up all of the different ways to express the solution. In a graph, this would be an interval of numbers from negative 7 to 7. We're going to use closed circles to represent that negative 7 and 7 are part of the solution set. And we're going to connect them with a nice straight line segment. When we connect the conjunction, we do not put arrows on it. This is a line segment and it has 2 endpoints. So it starts at negative 7 and it stops at 7, no arrows, the end. In interval notation, we would use a bracket and we would say negative 7 to 7. And that's how we would solve this one. For this example, we want to make sure that before we set up our cases, that the absolute value is isolated. And right now it's not because we have this plus 2 on the same side. So the first thing I want to do is take away 2 from both sides. Then I get the absolute value of x minus 8 is greater than or equal to 12. Now that I have the absolute value isolated, I recognize that we have the greater than, which is a disjunction, which means we're dealing with two distinct intervals of numbers. We have the numbers that are bigger than 12 or the numbers that are smaller than negative 12, because when you take those absolute values, those numbers end up being bigger than 12. So in one case, we're going to say x minus 8 is greater than or equal to 12. In our other case, so the other thing is that x minus 8 could be less than or equal to negative 12, right? Because that would put us at negative 13, negative 14, negative 15, all of which have those absolute values bigger than 12. In both cases, we want to get x by itself, so I'm going to add 8 to both sides, giving me x is greater than or equal to 20. Over here, I'm going to add 8 to both sides, and that's going to give me x is less than or equal to negative 4. And now I'm done. I have x isolated in both cases. So on a graph, we're going to be lazy here. Both 20 and negative 4 are multiples of 4, so I'm just going to count by 4s. It's not being lazy. It's using my resources, which I'm allowed to do. And over negative 4 will be a closed circle with the arrow going to the left. We're looking for numbers less than negative 4. Over 20 will be a closed circle, and that will be an arrow going to the right, because that's going to give me those numbers inside the absolute value that will be greater than or equal to 12. In interval notation, to represent x is less than or equal to negative 4, we would say it goes from negative infinity to negative 4. To say that negative 4 is included, we use a bracket, or these pick back up at 20, and there's no largest number larger than 20, so we would say to infinity. In this example, we have the absolute value of 4y minus 3 plus 7 is less than or equal to 20. So again, the first thing we want to do, isolate the absolute value. Don't make any judgments about this. Don't talk about which type of junction this is, whether it's a disjunction or a conjunction, until you have the absolute value isolated. In order to do that, I need to take away 7 from both sides. That leaves me with the absolute value of 4y minus 3 is less than or equal to 13. Now that the absolute value is isolated and we have a less than, this indicates to me that this is a conjunction. We're dealing with one single interval of numbers with 2 real number endpoints. So we're going to have a starting point and an ending point that are both real numbers. To set this up, we can use the compound inequality. I can say negative 13 is going to be less than or equal to 4y minus 3, which is less than or equal to 13. Now I need to get y by itself in the middle. So the first thing I'm going to do, I'm going to add 3 to the left, to the middle, and to the right. That's going to leave me with negative 10 is less than or equal to 4y, which is less than or equal to 16. Now to get y by itself, I'm going to divide everything by 4. I'm dividing by a positive, so I don't have to worry about flipping the inequality symbols around. Negative 10 over 4, while 4 doesn't go evenly into 10, I can simplify. It will be negative 5 over 2. Or you can say negative 2.5. So I'm going to just do a big less than or equal to. This would be y. Less than or equal to 16 divided by 4 is 4. So that would be the inequality, whichever way you want to write it. I probably would not write it the way I did, just choose one and that's fine. On a graph, I'm going to have -3, -2, -1, 0, 1, 2, 3, and 4. -2.5 is exactly halfway between -2 and -3. So I'll put my closed circle since it is included. And then 4 is right here, closed circle here. We connect them with a nice straight line segment, no arrows here for the conjunctions. And lastly, interval notation. We include the -2.5, so we use a bracket. That would be -2.5 to 4, also use a bracket. And this would be the final solution, representations for the solutions. All right, another example. So this time we have a little bit more work to do because not only do we have something being added to our absolute value, but also something being multiplied. And you may recall, you may not distribute inside an absolute value. You cannot do that. Instead, we have to treat the absolute value for now like a variable and get that -3 to the other side using division. We're not going to worry about that yet because the first thing I'm going to worry about is subtracting 1 from both sides. That's going to leave me with -3 times the absolute value of 0.5b minus 4 is less than -6. Now to isolate the absolute value completely, I need to divide both sides by -3. When I divide both sides by a negative, that's going to flip this inequality around. That leaves me with the absolute value of 5b minus 4 is greater than -6 divided by -3 is +2. So it flipped the inequality. We have the absolute value is greater than something positive, so that's good that you get into tricky situations when it's not. Because it's a greater than, this is a disjunction, so that's why we don't want to make any judgments at the beginning of the problem because it was a less than, which appeared to be a conjunction, but that negative flipped the inequality. It's a disjunction, it's an or. In one case, what's inside the absolute value can be greater than 2. In our other case, what's inside the absolute value has to be less than -2. Now we're going to get isolate b in both cases, so that's going to leave me with 0.5b is greater than 6. Then to get b by itself, you can either divide both sides by 0.5, that's fine. The other option is you can multiply both sides by 2 because 2 times 0.5 equals 1. So whatever you're comfortable with, just make sure that you don't make any weird mistakes like say that 6 divided by 0.5 is 3 because it's not. We're saying how many halves are in 6 and there would be 12 halves. Over here, we're going to do the same thing. We're going to add 4 to both sides. That's going to give me 1/2 b is less than 2. And then again, you can either multiply both sides by 2, or you can divide both sides by 1/2, and then how many halves are in 2? That would be 4. So this would be one representation of the solution. On a number line, I'm going to count by 2s, I guess. I could count by 4s if I wanted to, but we'll include a few more numbers this time. 12, 14, 16. b is less than 4 would be an open circle over 4 with an arrow going to the left. b is greater than 12 would be an open circle over 12 with an arrow going to the right. In interval notation, we would say, so b less than 4 would be -∞ to 4. And we use a parenthesis to say 4 is not part of the solution set, and same with 12. To represent 12, b is greater than 12, we would do 12, comma, infinity. And this would be the solution here. One more example. So this time, we need to get the absolute value by itself. We're going to take away 7 from both sides. We get the absolute value of x plus 5 is less than -4. I see a problem here because when we're dealing with absolute value, we should generally have a positive. It should be less than something positive or greater than something positive. Here we're saying that we're going to take the absolute value of something and it's going to be less than a negative. I don't think so. We can't do that. If we take the absolute value at the minimum, it's going to be 0. And 0 can't be less than -4. This indicates to me this is a contradiction and there is no solution. To represent this on a graph, you would create any number line you want. You can put any numbers on here that you'd like. Just don't put any open circles, closed circles, arrows, nothing. Just leave it blank. In interval notation, there's 2 ways you can open up a brace and close a brace and put nothing inside it because there's nothing to put in our solution. Or you can do what's called the null set, which is like a 0 with a slash through it that like negates it. Either one of those is fine. You cannot combine those two. So this would be how we would represent this scenario.